Welcome to OUE Today. OUE Today is a public affairs presentation examining issues and topics of interest to the Ohio Valley. I'm David Castle, your host, and tonight I'm going to be speaking with Dr. Thomas Blaine, Associate Professor, Ohio State University Extension, who's going to be speaking tomorrow night, Tuesday, April 29th at 7 p.m. at Horizon Hall at Belmont Technical College. His topic is going to be Global Climate Change Update 2008, a review of the evidence and outlook to the future. Tom, thank you for being my guest tonight.
Thanks a lot for having me. It's great to be here.
I'd like to start with maybe you just providing a little bit of background about sort of who you are, where you came from in terms of arriving at this topic and as a topic that's of interest to you and something that you're doing presentations about. Why don't you tell us a little bit about your background?
Well, okay, I was born and raised in northeastern Kentucky, near Ashland, Kentucky. Went to the University of Kentucky where I studied political science and then later marketing, and then finally I entered the program in natural resource economics. I've been interested in environmental topics, and I'm also interested in the interaction between the economy and the environment. And so I've studied a whole number of environmental topics, everything from recycling to global warming, conservation, preservation, pollution, all kinds of things like that. Over the years, during my career, the topic of global warming and global climate change emerged as probably the most widely discussed environmental topic in the world. So I couldn't resist studying that and then writing and teaching about it.
Well, in fact, you're making your presentation tomorrow evening at Belmont Technical College as part of the higher learning collaboration group of Ohio University Eastern, Belmont Technical College, and Ohio State University Extension. Is this part of what you do for Ohio State University, talking to the public and bringing to them sort of topics of scientific interest and importance?
Yes, that's exactly right. My position with Ohio State University Extension is to take the university to the public. That's what Extension does. That's what Extension's all about. And so my job really is to do this, to attempt to educate the public in general about a range of topics within my specialization, environmental and natural resource economics.
Well, let's talk a little bit about the topic for tomorrow evening, Global Climate Change Update 2008. In reading about what you're going to be doing, it looks like you're going to kind of give the audience an overview. Why don't you tell us a little bit about what you intend to do and what sort of materials you'll be covering in tomorrow night's talk?
Well, my major goal in tomorrow night's talk is to try to put into perspective the changes in global climate that we read about in the media and so forth all the time. We're constantly bombarded with articles right now about changes in global climate and temperatures and statistics and things like that, but we rarely get to see the context in which these changes are taking place. Earth's history has shown that climate has always changed. There have been dramatic changes in global climate really over the last billion years. That's the history that I discuss. And so I want to talk about those changes. I want to talk about the causes of those changes. And then I come closer to the present and actually talk about temperature changes and climate changes just over the last few years. So I hope by doing that I'll be able to put those changes in context so that folks can understand a little bit about the history of climate change in general, and then more specifically about what kinds of changes are taking place now.
Well, I want to talk to you some more about the issues related to what's in the kind of the popular media and the newspapers and some of the even what seems to be kind of political controversy about the whole issue of global climate change. But let me ask you a couple of sort of scientific questions. I'm not a scientist, I'm a historian, but in your presentation you talk about the climate, the global climate, starting maybe about 1 billion years ago. How do we have any idea about what the climate was back then? How do we know that?
Well, modern methods of measuring and recording temperatures really started about 1850 to 1860. So generally speaking, when we're talking about temperatures since that time, we're talking about actual measured temperatures. But anything prior to that comes to us from what we call proxy data. And proxy is something where you try to measure something by measuring something else, if I could say it that way. Basically, scientists go back and they look at sediments, they look at ice cores, tree rings, all kinds of things like that, from which they can try to construct a climate record. This is a whole science in and of itself. Scientists go to Greenland, for example. They go to the Antarctic. They go all over the world studying sediments, ice cores, things along that line. Generally speaking, you dig down into a sediment or you dig down into ice, the further down you go, it's like looking back in the time. Scientists have developed all kinds of different markers for trying to estimate what temperatures were on the basis of those markers. For example, if you want to look at tree rings, as you probably know, trees, when you do a cross-section of a tree, you cut a tree down, you look at the cross-section of it, there are rings, and there's one ring for each year. But the distance between those rings can tell you quite a bit about what happened that particular year, whether the conditions were dry, cool, and so forth. And when you gather a number of those proxies together, you can construct a climate history. And, of course, the further back you go in time, the different kinds of proxies you have to use, as I say, sediments, ice cores, and things like that. But because of all these kinds of proxy data, scientists have been able to construct data sets on estimated or proxy temperatures all the way back to the Cambrian era, which is roughly a little over 600 million years ago toward 1 billion years ago.
Well, as you were talking, I was thinking about trees and tree rings. I did know that, you could tell something about climate from that. I remember reading about those sorts of things. Of course, trees, we would only be able to go back, what's the oldest tree? Probably not more than a few hundred years old, right?
Well, again, you have living trees, but then there are also fossil trees that are no longer living, but which have left a record. And anyway, it's true, yes, that the further back you go, the different kinds of proxies you have to examine. So, yes, tree rings from living trees could potentially give you data back to a certain time. Beyond that, you would begin to look at ice. Ice is a very important. Ice has become probably the most important item from which scientists measure ancient temperatures, because the ice in places like the Antarctic and Greenland, that ice has been undisturbed. Again, the further down you go into that ice core, it's like looking back into time. There are bubbles formed in that ice and layers, because each year you get a new layer of precipitation, and each time there's a layer, there's a boundary to that layer, and so you can go back and just count those and continue to go down deeper into the ice core and look further back into time. Scientists have been able to identify, for example, carbon dioxide concentrations and temperatures on the basis of those ice cores. It's a fascinating science. It's one that scientists have developed quite a lot of very good techniques, very reliable techniques for measuring proxy temperatures from ice core data.
Well, in fact, that was one of the things I was wondering. Is this science of looking at the ice cores and measuring, determining temperatures and carbon dioxide levels and so on, scientists feel very confident that the data that they're getting back, into these long stretches of time into the past, they're fairly confident on the accuracy of this information?
Yes, the ice core data is very reliable data. There doesn't seem to be any controversy whatsoever about actual ice core data. I think that there is a consensus on the ice core data that it is very, very reliable data. It's high-quality data because, again, the ice has been undisturbed. I mean, if you go to places like Antarctica, we don't have a human footprint there. Mm-hmm. Even most of Greenland, we don't. So these ice cores are undisturbed. They're a pristine record of global climate. The techniques are pretty straightforward. This is a very good climate record.
Well, that brings me to my next question. And you obviously, as part of your research on this, you've gone through this data and looked at this process. It's going to be part of your presentation tomorrow night. What does the data show? I mean, one of the things you kind of hear people say is that, well, the climate has always been changing and it goes through cycles and it gets warmer and then it gets cooler and then it gets warmer again. is that all true? And if it is true, does that change the nature of the debate in looking at what's happening right now?
It's true that there have been enormous variations in Earth's climate over time. That is absolutely true. When you ask the question, what's the cause of these climate variations, it depends on the scale of time over which you're looking. So if you're looking, for example, over a scale of millions of years, the answer to the question of what causes climate change over millions of years is going to be a different answer than what causes climate change over, say, thousands of years. And then it's going to be a different answer when you ask the question, what causes climate change over 50 years or 100 years. The scale is very important here. Now, for example, when you talk about over millions of years, what causes climate change, the main cause of climate change over that period of time is continental drift. You're probably aware that continents move, and the globe, the surface of planet Earth, looks quite different now than it did, say, 100 million years ago, because the position of the continents has changed. And because of the changing position of the continents, ocean currents change. Ocean currents distribute heat from the equator toward the polar regions. When those currents get blocked by continents, it changes global climate quite a bit. However, continental drift does not occur over decades or thousands of years. It changes over millions of years. The continental drift is a very slow process. However, it has enormous influence on global climate. When you talk about narrowing the scale a little bit to tens of thousands of years, the cause of climate change is something different. It's no longer continental drift, but now it becomes an issue of Earth's orbit. The Earth's orbit has changes to it. It's really not a constant orbit, because over periods of thousands of years, there are changes that regularly occur in the orbit of Earth around the sun. These changes cause the climate to change, and these are the changes. Earth's orbital changes are the changes that cause what we now call the ice ages. You're probably aware that about 10, 15,000 years ago, Earth was coming out of an ice age where, for example, here in Ohio, most of the state, or much of the state, was covered by glaciers, a totally different environment than what we know now. Well, that ice began to melt about 10,000 years ago toward giving us the kind of Earth we have today. You have to ask the question, what caused the ice age to come on and what caused it to leave? And the answer to that question is that it's Earth's orbital change that causes those ice ages. Now when you come down to shorter periods of time, like hundreds of years or decades, the causes again change, causes to global climate and global warming and so forth. Those are different kinds of things that cause changes to come about at that scale. So that's why I'm talking about all these different scales in my presentation, because I want people to understand that it's true that global climate has always changed, but the reasons for those changes tend to be based on the scale of time that we're talking about.
Well, I guess the crux of the question may be then, and part of the debate is whether the changes that we're seeing in the last 100 years are unprecedented and somewhat irreversible. I mean, or maybe not irreversible, but I mean, there's this crisis that some are arguing that things need to change, or we're going to be damaging the environment and the earth in new ways than have happened in the past. Because a lot of what you're talking about sounds like, a cyclical process. The orbit changing over time, the slow movement of continents. And I don't think people would be, as worried about sort of that kind of long-term change. They may not think that it's going to affect them, but certainly some of the arguments that are being made now are that, in the next 20, 30, 40 years, we could see drastic and very dangerous changes.
Well, again, we're talking about the scope of time. Obviously, we're talking now down to decades. What's going to happen to planet Earth in the next few decades, and the related question of what's happened to global temperatures over the past few decades or past 100 years or so. So now we're really outside the realm of continental drift. We're outside the realm of Earth's orbital changes. So we have to ask ourselves these questions. Why is the temperature of planet Earth warming now? And when I say now, I'm talking about in recent decades, as you are. Obviously, we can rule out continental drift. We can rule out Earth's orbital changes. The question becomes, is human activity influencing global climate? And it appears that it is, because carbon dioxide is a greenhouse gas. Carbon dioxide is a gas that contributes to the warming of planet Earth. It is a gas that occurs naturally, of course, in the atmosphere, but human activities, really since the time of the Industrial Revolution, have caused an increase in the atmospheric concentration of CO2. And there's no question whatsoever that the increase in atmospheric CO2 that we're seeing is caused by human activity, specifically by the burning of fossil fuels. We're talking about gasoline, coal, oil, and natural gas. So the increase in CO2 concentrations that we're seeing is being accompanied by temperature increases. And I want to be clear about the temperature increases that we're seeing right now. We're seeing a temperature increase of about 0.2 of a degree Fahrenheit per decade. That's the trend right now, about 0.2 of a degree Fahrenheit per decade, which is roughly a degree Fahrenheit we've had over the past 100 years. It is not really common to have that kind of temperature change over that short a period of time. Given the fact also that we can rule out the other kinds of changes influencing this, it becomes rather evident that human activities are contributing to the greenhouse effect and therefore to global climate change.
Dr. Blaine, let me just take a moment to remind our listeners that they're listening to OUE Today on 89.1. We're talking with Dr. Thomas Blaine, who will be giving a talk tomorrow night at Belmont Technical College on global climate change. Dr. Blaine, why, if the evidence seems to be there that the temperature is rising and that this rise in temperature seems to be unusual and seems to be associated with human activity, if the science is pretty straightforward, why do you believe that this has become somewhat of a politically charged topic, the issue of climate change?
Well, I think it's become a politically charged topic for a number of reasons. For one thing, environmental topics a lot of times are politically charged, as you're probably aware. I mean, you can name an environmental topic that's made its way into the headlines and so forth. Think back on that a little bit, and you'll recall a lot of politically charged discussions and debates about that topic. You know, the spotted owl, you may recall the spotted owl was found in the Pacific Northwest, and then the question came as to whether that habitat should be preserved or whether there should be logging allowed in that habitat. And you had lots of debate over that, to say the least, a lot of protests and things like that. So when it's come to endangered species, that's been a politically charged kind of issue. This one, though, is global, so it's not just associated with that one species or one species here or there or a toxic dump here and there. Those kinds of things become political, too, but we're talking about something global, globally reaching. And so for like another, comparing that, for example, to other environmental topics, we could see this one would be the perfect kind of topic to have a lot of political debate over. Now, conservative folks tend to line up on one side of this issue. Specifically, conservatives have tended to be on the side denying that global warming is happening or denying that humans are causing it if it is happening. And liberals have tended to say that it is definitely happening and we need to do something about it. Again, that should not be surprising either, because it's more in the conservative tradition to want to hold off on taking aggressive steps toward the environment while on the liberal side, you've tended to have a lot more environmental activism. So it really shouldn't be that surprising that conservatives are saying, let's hold back on this and not get too premature in making a lot of decisions that could hamper economic growth and so forth, while you have a lot of liberals saying, no, we need activism, we need to do something now to save the planet. It really shouldn't be all that surprising, given what other things have happened with respect to environmental topics over the past few decades.
Well, in fact, I'm from Oregon, so I remember the spotted owl controversy actually quite well. And I remember there was the snail darter that was, I think, in the South, where they were thinking about some hydroelectric developments. But it does seem that the issue, the environmental issues, get tied very directly to economic issues, and then it becomes sort of a matter of one will be good for one course of action may be good for the environment, but it may have some negative consequences for the economy or for certain sectors of the economy. As a scientist who's looked at this issue, what level of urgency do you feel that there may be that the issue has to be addressed and maybe even confronted soon and with some vigor?
Well, I think that the issue is being confronted now. We're having political discussions about it. We had the Kyoto Agreement back in the 1990s, an international agreement. Now, the United States signed that. President Clinton signed that, but the Congress did not affirm that. So the United States has not abided by Kyoto, but a lot of countries have been abiding by it. There is a lot of discussion now about having a quote-unquote new Kyoto, in other words, a new international conference where a new regimen will be discussed in coming years. I believe that will probably take place. We're seeing a lot of political leaders in the United States talk about this issue. We're seeing more and more political leaders from both the Republican Party and the Democratic Party start to have dialogue about this topic that really we didn't have just even a few years ago. I think that's been a very interesting development because once we start having that kind of discussion between political leaders on both sides of the aisle, the Democrats and the Republicans, I think that probably we will have a lot of cooperation on it in the future, and probably by the next time there is an international conference on this, the United States will be able to enter into a dialogue internationally where we can have an agreement. But that remains to be seen. I really don't know that that's going to happen very soon, but I would say that over coming years we will see more development in that. Also, when it comes to the private sector, I know that a year or so ago, ExxonMobil came out and stated that global warming is a very real issue, that it's actually taking place, and that action needs to be taken in order to deal with this. I think, again, that was a very important development because ExxonMobil is a very large energy company, oil and gas and so forth. And you have a company of that stature talk about this as this very real issue. That's important because when it comes to new technologies that can change our reliance on fossil fuels and so forth, ExxonMobil is precisely, and other companies like ExxonMobil, these are the kinds of entities, in addition to government, that we would expect to be playing huge roles in developing technologies that help either wean us from fossil fuels or help to reduce emissions of CO2. They're going to help us deal with this issue.
Well, Dr. Blaine, I want to thank you very much for speaking with us tonight. And I want to remind our listeners that Dr. Blaine will be speaking tomorrow night at Horizon Hall at Belmont Technical College, April 29th, 7 p.m., and his topic will be Global Climate Change Update 2008. You've been listening to OUE Today. OUE Today is a public affairs program of Ohio University Eastern. I'm David Castle. Our producer tonight is Jay Morris. Thank you, and good night.